Okay, we are online and recording. Excellent. Thank you for showing up on this snowy Friday afternoon. Um, and a couple more people coming. I'll let them go, but I want to get started and get going. Let's see here. So we survived the midterm. Hopefully, it wasn't too terrible. Um, a couple people had some issues with connectivity. I don't know what happened. It just kind of crashed on them, so we reset it. So if you ever had an issue like that, just contact me as soon as you can and I'll reset it for you and go. It happens. And it's really obvious to me because I'll see like got to a certain point and like all the other questions there's like no it says no answer given. So it's obvious that you didn't complete it. And usually the time that you have it's like 10 minutes or 20 minutes, it's like really quick. So something blows up on it or something like that. So just something to be aware of. So midterm is done. Yay. And we're going to start off in Unit 7 and talk about characters and strings in the book. This stuff will build up into, and then get into arrays and exception handling. So these will all build up into our project. I'm kind of have the project set. I'm kind of still tweaking a little bit and making some changes. It's kind of what I talked about, I think, one time earlier in the semester. I think we might still do a exam similar, but it'll be smaller. It won't be the 20, it might be like 10 questions, just kind of sampling from each, maybe like 2 questions from each unit that we're doing, because I didn't have it, do any testing on some of the other stuff. So, um, might be like a 10 question exam like we did already for the midterm, and then I can give you a little bit of time and we can talk about the project at the end of each class, as I promised before. And again, what I'm thinking of is you're going to design an application. The one idea I had was to talk about was this dog rescue application where you're going to um, keep track of information about dogs that are coming into this rescue shelter that you work at. You've been asked to write an application because everything they do is on paper and it's driving them crazy and they lose track of stuff or they use spreadsheets and things like that. So you're going to create an application in Java and it'll track the dog, maybe the breed of the dog, maybe the name of the dog, things like that, how much their vet costs are, how much the food costs for the dog. So you can also help with budgeting. Just some very basic stuff and have a menu system that you'll create and set up. And I'll show you some examples to do that. And you can be creative. You can do it very command line, how we've been doing everything in JGrass. You can use NetBeans, you can use Eclipse, whatever you want to do. Or you can use the graphic, you can use JApps and Paint, and you can make it all graphical. Like I think I mentioned, I had some students who did similar stuff like that, and they did everything graphical. Um, I'll show you kind of what I was thinking of, just so you know. Let me go to the learning units. Like I said, it's not quite ready, but it's almost ready. Kind of go into, I put this out here just in general. Any programming class typically you take, these are kind of the steps that you take with that. And so I just kind of reiterate that and make sure you just think about that. As developers, and I'm very guilty of this as well, is trying to jump in right away and just start doing stuff. And that's not really good. No matter how small you think the project is, for what you're doing, it's always a good idea just to take a couple steps back and plan. Think about it, what you're doing. I'm doing a simple project right now at home. I'm putting some shelves up, but instead of just throwing up stuff right away, I'm taking some measurements. I'm figuring out if what I want to do is going to make sense, that kind of thing. So I'm just taking a little extra time because a little bit extra time on the front end helps. So again, these are the very simple, the typical steps. These have been around for a long time for the software development lifecycle. Analyze what the problem is. Why are you even running code? What is the situation? So in this case, it'll be the project. It'll be you want to automate some processes that are at this dog shelter or this animal shelter rather to help the process. Then you're going to start working on and you've decided, hey, I figured out what it is. I want to feel it. I think I can do this. I'm not going to do anything too big. It's always good to start small. Then you go to the design phase. You just even if you write on paper draw it out with a pencil and paper, use crayons, use whatever you're comfortable doing. The design aspect does not have to be you doing stuff in JGrasp or Microsoft Word or anything fancy or PowerPoint or Visio, anything like that. If you want to and you know those tools, go for it. Once you kind of have a design, what you think it's going to be like, and normally what happens is some of this is when you're doing the analyze part, you're going to be talking to the user who's doing the requirements. So in this case, I'm the user. I put the requirements out for you. So if you have questions, you can obviously ask me. And then you do a design. And if you come up with a design of what it should be like, now I'm going to give you some ideas of what it could look like. And you can go with that. It doesn't have to be exact at all. Again, and give the same programming assignment to 10 different students, it's going to come potentially back 10 different ways. It doesn't mean any of them are wrong, just different ways you can be creative. And it's kind of an iterative process with the design. You might do some design work and then start doing development work. And that's the bulk of your work, design and develop, going back and forth to make sure that what you're doing is going to work and it's making sense. And it's what the end user, in this case me, would want, or whoever the end user is. Because again, the last thing you want to do is create a project or application that you give and they don't like it. They don't want it. 3 months, 6 months, whatever down the road. And then obviously the last, not the last thing, but the second last is testing. But you're going to be doing what's called unit testing all along the way. So every time you're writing code like we do it, we test it, right? We run it. We run the application. We test it out. We make sure things are going okay. A lot of testing, making sure it's tweaking. So I had 2, 3 lines of code. I test it. So you're going to be doing that the whole time. When you think you're all done, you'll test it. And what I would recommend, and a lot of times recommend, is have someone else test your stuff. Have a fellow student, have a friend, a family member say, hey, maybe it's ideal sometimes when you give something to someone who has no idea what you're doing. And that's a lot of times when you give it to a tester, a QA person, quality assurance person. They don't know what it is. They have a general idea. Oh, this is some application that's supposed to keep track of dog rescue information. And they would then test it out. And they play with it and they beat on it. So they're going to not think the way you are potentially. They're not programmers. They just try to use it like a regular user intuitively. And is it intuitive? Does it make sense? And at the end is your part of your finalizing evaluation, maintenance, and that's also documentation. You have to do any documentation. Now we're not going to get too into all this, and I'm going to lay out a lot of that. And I'll kind of show you what I was thinking. Some of the stuff. These are some sample menus that I created before. I'm going to tweak them, so don't hold me to it. I might make some changes still, but you might have a menu system like this, and I might add some more stuff. I'm still tweaking it, or maybe you add a dog. I've gotten dogs come in, you display dogs. It's very primitive, yes, but I want to keep it simple. Just again, get the idea. And the idea is you're able to do a lot of different functionality we're doing with classes and those type of things. So the rubric will be based on using classes and loops and getting information from the user and feedback and doing some calculations. Because you can see I can add dogs and display, in this case I'm displaying the dogs that were put in the system and the costs. And what costs are they? Like for a vet or food costs. Because when you enter a dog, for example, it shows you I'm adding a dog. This one is, name of the dog is Mari and the food is $50 and the vet cost is $75. I'm not worried about formatting. If you want to format it, make a nice currency, things like that, that's great. This interface here in Blackboard doesn't show you everything, doesn't show you the screenshots. The PDF has everything, which again, I'll make available as soon as I finish it. But some things like I'll ask you about the classes, do that, creating classes, arrays. So generally, this is what it's going to look like, that kind of thing. Creating different methods, and this is stuff. So a lot of this stuff you've already done already. We haven't done arrays yet. We haven't talked about that. We've done classes, getters and setters. We've done loops and display. So a lot of the stuff you can do already. You can start to get the head start. So I might even open it up by the end of tonight, so you can start and get a head start on it. But that's kind of the idea. Okay, so that'll be the project, along with maybe like a 10-question exam, something really simple. Again, online. And then here's the deal also, similar with the midterm, I'm not going to there's no presentation. I'm not going to have you do that. I'm not going to ask you to do any of that stuff. So I'm going to leave that last class date up to you, how you want to do it, just like we did the midterm. I'll make it available to you. Who knows? It's middle of December. May have good weather, bad weather. Who knows? We might have another couple of feet of snow. I'll leave it open for you, and I'll remind you of that. But obviously, it'll be time that you can have here in class if you've got questions, you're stuck on something, that kind of thing. So, but if you finish it ahead of time, hey, that's fine too. And like I said, just like the midterm, I'll open up the midterm, the final ahead of time, just the questions, those 10 questions, so you can take them when you want to. Did that help you? Was that flexible for you? Kind of worked? Did you kind of take it when you needed to? Yeah, I'm not really big in like, okay, everybody show up on this day because inevitably someone isn't going to be there. Obviously, with the online students, I have no choice. I have to, but all right. Any questions on any of that? I know I threw a lot at you. And I'll open that up. I'm just going to, like I said, finish tweaking a couple things with that. So this week we're going to talk about characters and strings and string builder. It's an important part of any language, not just Java, just any language. So unit 7. Strings. We've got 3 UDoITs that we're going to do this week. That I'm only ask you, there's a bunch more in the book, but I'm going to ask you to do all of them. Again, we're just going to be playing, manipulating strings, that kind of thing. And then the assignment is just you actually have one exercise in chapter 7. That one is a valid password one. You're going to create your own password validation program. And you'll see in the book too, I think it's for the repair name.java, which we'll do. We do use Java. Again, and so again, start to think about what you might want, how you might want to approach the project as well. And that's why I want to get it going and talking about, so you have plenty of time to do it. Because it is, what is it? It's November. Back to the schedule here really quick. So it's November 1st, right? So really got this. We got 1, 2, 3, 4. No one does anything during Thanksgiving. 1, 2, 3, 4. Technically, we have 1, 2, 3, 4. What? 5, 6. 6-ish weeks, roughly, right? If you count the final exam week, that's 7. So 6 to 7 weeks, depending on how you manage your time. And I know obviously you've got other classes going on as well. So, all right. So let's have some fun. Yay. Strings and the string builder. Strings. And we talked a little bit about some of this stuff before, about how you compare strings, those types of things. String class, a character class. I'm going to kind of skim through some of this because this is kind of boring. String is not a data type. So the primitive data types in Java, some of them are like what, integer, Boolean, right? Float. Those are what's called the primitive ones, are built in. Whereas string, on the other hand, is a class. So we use string, and thus it's actually capitalized. String. So string is a class. It's not, it says right there, it's not a simple data type. It holds a place of memory. So when you create a string, it actually, like anything else, a data type, it creates a place in memory for that value. So whatever it is. So the name. So my name is Chris. So Christopher. However big you want to do it, that kind of thing. It creates memory space for that. So it stores it for later. And you'll do that. And I can compare strings, but you're not going to compare strings in the conventional way that you do with, does 1 equal 1 or does 2 equal 2, those kinds of things. It doesn't work the same way in string. So the string class uses methods to do that, to do some of that stuff. Because what's happening is you're not really comparing the values with a string class. What you're doing is what they say is they're comparing memory locations. So there's a chance that if you compare them with an equal sign, it may equal. So you may actually, if you accidentally code that one time, where you say there's, the string A equals string B, it may be true once or twice or whatever, but don't guarantee it, because again, it's just a memory location if you have that. Otherwise, you're taking a chance. It's not the way you want to do it. Just kind of way it's made, and they give you an example here. So if you say if a name is a string, which is Carmen, and if I literally type in Carmen again for the other one, that doesn't mean it's going to equal. So you don't want to do if string 1, in this case a name, is equal to another name. Don't do it. That's all. So those are little things you have to be aware of, and in order to do it, there's a method in order to do that. And I thought they'd sure, and I'm going to go back. Let me go back to that for a second. So there's a method. Yeah. So let's go. Talk about it, equals. Like that. Yep. Okay. There's a whole bunch of functions that we can use. Like I said, including the equal when you want to compare strings. And I'm going to kind of go through some of this kind of quick because I don't want to bore you with the PowerPoints. If you get strings, there should be a list of functions. There's all our functions. So commonly used methods with the characters and strings. A character is just one character, one single letter, where a string is a whole bunch of characters together. But you can use these different methods for that to do different things. So I can change a string that someone enters in. I can make them all uppercase. I can test to see, is it uppercase? I can make it uppercase. I can decide if someone enters something and I want them to enter, like with our program example with the dog rescue that we're going to do for a project. I can verify if they entered a number or letter, something valid. Hey, I want you to enter number 1 through 5. I believe we did some of that with the loops last class, the loops, playing with some of that stuff. But you can do that, and you can say, one of the things you can say is it, first of all, is it a digit? You know, hey, if it's not even a digit between 0 and 9, I'm not even going to get there's all these checks on the front end. Remember, I talked about it a lot, and you probably hear it in all the programming classes, GIGO, garbage in, garbage out. So you want to capture as much as you can on the front end so the user can't enter garbage in there in order to get it. So if they're expecting something between a 0 and a 9, and you enter letter A, it should not get in there, right? It should not get past it. That's the whole idea. So you've got all these different methods that you can do stuff. If someone enters a password and it should be lowercase because maybe it's passwords. Passwords are case sensitive typically, right? Because you're doing upper, lower, you're doing alphanumeric, all that kind of stuff, symbols sometimes. But maybe with the username you want it to be all lowercase. So you could take whatever they enter in and you could just convert everything to lowercase. You can automatically do that, so you know. Things like that. Hey, is it a letter? Is it uppercase? Is it lowercase? So these are very helpful when you start getting into some of that stuff when people give you information. Is upper, is lower, is it digit, is it white space? Whatever the case may be, what is it? So it's really kind of nice, kind of helpful. They have you look here in one files. So we can put a couple things here. Let's do this. Let's do this. You know, we can kind of, we can kind of but that's all right. Let's talk a little bit about this and I'll jump into this. With the characters. Again, is uppercase, is lowercase. Again, we got all the methods to test this out. And they have some sample code that you can actually look at. You can copy and paste this just to do the same thing, to check it out, which is kind of nice. And what happens in each system? So if you've got a char set up called a char and it's a capital C, remember a capital C is different than a lowercase c. They are not the same. Right? They have a different, what's called an ASCII value on the table, on the ASCII code table. So a capital C is different. So if you just happen to do that, you're like, oh, it's a C. Well, now if you don't care if something is entered as upper or lowercase, then again, you might have to do some of these conversions. Because again, when you compare them in Java and other languages as well, it's going to say it's not equal, just like we were playing with before. With the string, with they said Carmen again, hey, it's not equal. It's not equal. You can't do that. So they give you examples of using these functions. Again, digits. This could be useful for you again if you do that a menu system or anything like that. You can check to make sure someone enters a digit. Make sure they enter something between 0 and 9. Is it a digit? You know, you can have a boolean in there. So did they enter something between 0 and whatever? So let me go back to that menu really quick, just as an example. I'm gonna keep jumping back and forth, even though I haven't opened it up yet. You know, I haven't made it available yet. You can see it on the screen. So right here. So in this case, right, you'd want to say only accept valid numbers between 1 and 4, right? Well, first of all, only accept entries between 1 and 4, and it should be a digit, right? In this case, just for this example. Because you may have menus that have accept letters or whatever. I mean, doesn't mean you can't do that. But in this case, you don't. So this you'd have something like that. So and again, the idea is again, so they can't enter something. They can't blow your computer up. Hey, I'm gonna enter a 5. Some people do that on purpose. They love to do that. I had a QA person that was awesome. Literally, I think I may have mentioned to you guys that I would give her so I'd be so happy. I finished the code. I'd be working on it, and I'd be like, "This is good. This is done." And I'd give it to her, and literally within like 10 minutes, she'd break it. I mean, she was good. It was a combination of she was good, and I was actually still early. Combination, probably not a great combination. So within like 10 minutes, sometimes you find stuff, just stupid stuff that I would do, and that's how you learn. You figure this stuff out. But again, it's just part of that. So she would do something like that, where she would potentially enter a 0, a negative, kind of things that we were doing before. Things like that you got to think about. You know, how does that going to work? Remember, users can do anything, right? They do all kinds of wacky stuff, so you got to be ready for it. So the string class, just so you're aware, is in the java.lang for language.string. And it's automatically in every program. So you don't have to actually add it. We add the scanner class when we're doing the input from the keyboard. And sometimes we'll add the option pane. We import that if we want to do the graphical interface, that kind of thing. But for string, it's automatically part of it, so you don't have to worry about it, which is kind of nice. Very kind of nice. Really, really kind of nice. So let's see here. So again, here they had talked about comparing strings. And we can play with, we could, here. So let me do a couple more here and we'll write some code. So again, each string is a class, each created string is a class object. String is a variable name. It refers to a location in memory rather than a particular value. And again, that's the issue when you're trying to compare strings. You just can't do that way. Let's see. Ways you can create strings. I can create string, just call it string like we've done. String equals new string, or just say string. And it implicitly will create a new object. So you don't have to do the new string. When you just do the second line here, implicitly it knows to do that, which is really kind of nice. So you don't have to explicitly do that. And most of the time, the code you'll see is string, the variable name, and set it equal to something. And I highly recommend, if you can, set it equal to something, even if it's nothing. If it's an empty string and you quote, so at least you've got some value in there. But you don't have to do that. But you can, like I said, explicitly cause that constructor. So let's see here. And this is the example talking about memory. Just kind of give you an example. So if you've got the string a greeting, in that case, it's just talking about memory locations. Again, it's just kind of reinforcing that. And it's in the book too. It talks about that as well. All right, let's do this. So in order to compare two strings, how do you do that? You use a method called compare_to. So you would take string 1. In this case, they have a string called a word dot compare_to. So compare_to is the actual method that you use to compare it. And it will tell you. So again, and it compares the two strings. It's 0 if the two strings are the same value. So when you check it, just check if it's 0. If it's 0, hey, it's the same value. Now, you can also get a negative number or a positive number. If one is less than or more than, we can get into that because, again, technically strings can have values if you want to worry about that. But really, realistically, most likely what you're going to worry about is if somebody enters a string value, you're just going to want to maybe check if it's equal and go from there. And just check if it's 0. So when you do the compare_to method, you want to make sure that the value you get back is 0. Because what did I ask you to do? Let me double check here. Because we want to do repair name, number input, and right. And then number input. Person. Okay. That's a different one. Okay. Oh, we could do a couple of things. Let me open up JGrasp here. Thought I had it open, but I don't. No, I don't want that. I want JGrasp. Close all tabs. JGrasp. Okay. And you don't have to do this. I'm just gonna kind of do a couple things here. Just to. All right. I was playing with some other code. So here I can create a new. Yeah. Well, actually, I'll create a new one. File new Java. You can do it if you want. Public, static, public class. I don't know. Call it string test. String test. How about that? You can do that. And open curly, close curly. Just kind of give us something to play with here. And then we'll do the public, static, void main, string, args, open curly, close curly. Okay. So we'll create a class called string test. I'll do a capital S too. I don't like my classes being like that. So public class string test. I'm going to save it. I don't think I have one called string test. I'll find out in 2 seconds. I do. That's right. I'm going to write over it. We'll save it again. Okay. So a couple things you can do, and again, I'm just going to play with a couple things here to show you. So I can do string and do, I don't know, F name, the first name. And I can initialize it, which is a double quote like that. And I like doing that typically. I like to initialize variables because then if I try to access them later, I don't have an issue. I'll make another string, call it L name for last name. Like so. Okay. I'm not going to get any input from the user at the moment. I can do that. And I can say F name is equal to Slarty. Don't pick on my names. L name is equal to Bartfast. Have I asked you guys this before? Do you know where this name comes from? Have you ever heard this name? There's a book. You guys ever heard of the book Hitchhiker's Guide to the Galaxy? That's where it comes from. If you have not read it, there's a movie which is okay. Book is good. The record also with it. It's been around a long time. It's kind of goofy, but it's kind of interesting. Okay. Highly recommend it. Anyway, Douglas Adams is the author. So I've got names here, and I can play with some stuff. So let's just do this. So system.out.println, say name, say full name, and we've done some of this. I can type full name. Jeez. Plus, there's my concatenation. So it's F name plus L name, like so, right? Don't forget your semicolon. So something very simple. Let's just see if I'm going to build this. Play with a couple things here. And I'll run it. And it spits out my full name. You'll notice there's no space in there because I was lazy. I didn't concatenate a space there, which I can do. You can be like, oh, I should do that. I should make it look better. I'll make it. So I should do a space right there, right? Quote, space, quote, plus. Again, my whole thing is get it working and then go back and tweak it. play with it, format it, get it nicer. So now, hey, I've got my space there. I've got my full name, concatenation. So let's see, we're gonna do something really simple. We can check, because if I go back to, so compare to is the actual, and if you're not sure, you just copy the syntax. I can type it too, it doesn't matter. I'm lazy though. So I can do this. I'm going to do something really obvious. I'm going to say if f name. I'm going to compare it to L name, right? I'm going to say if it equals 0, and curly, else, curly. So let's see if the f name is equal to L name. So if f name is equal, I'll do system out print ln. Say equal, right? I'm going to copy this line like that, paste that. Don't do that. Okay. Not equal. Not equal. Okay. I know it's a very simple test, but again, that's sometimes it's kind of nice just to make sure it's doing what you think it's supposed to be doing, right? I'll make it a little bit smaller so you can see it better. And then I shall run it, and we should get what? Not equal, right? So we should get the full name, and then we should get not equal. There we go. Full name, and then we get not equal. Not very complex or complicated, but again, it proves the point. I can create another string at the top. I'll say, I don't know, a test name. And I'll say Bartfast. So I'll make test name the same as last name. So let's see what it tells. Is test name, I'm going to compare test name to L name. So L name is already here. So I'm going to replace first name, F name, with test name. So if test name dot compared to L name is equal to 0. So now test name is Bartfast and L name is Bartfast. So technically, so it should be equal, right? Let's see. Not equal. What happened? Test name is Bartfast. Did I make a mistake? Because it's either equal, less than, or greater than. What did I do? If test name compared to L name is Bart. Oh, I misspelled it. Test name is Bartfast, and here it's Barfast. Whoops. There's a boo-boo. It's made a boo-boo. I'm sorry. I'm going to rebuild it and rerun it, and this time it does equal. Okay, I thought I was losing my mind for a second, but I mistyped. So there you go. So those are equal, like that. So we know that works. So that's a nice, easy way to check some stuff. Some people, I've had students who have made like role-playing games, RPG games, and they'll do stuff, you're in a dark cavern, blah, 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 pick a direction, and they'll have, the user has to, now you can have them type a number, or you can have them type a letter, north, south, east, west, up, look down, squat, all these, you can do all these characters and build your own RPG game. You can do all that kind of stuff. You can do it with numbers too. I think it's probably easier if you use letters for some of this stuff. And then you would and what would you do? So if you had a whole bunch of input potentially from a user, you'd probably use like a case statement, like a switch, right? Because they can pick any letter, whatever letter it would go through, that kind of thing. Something like that. Potentially you could use the case or switch statement with a menu, right? Which one did they choose? get the menu item. They chose 1, 2, 3, 4, 5, whatever, how many there are. It could be something like that as well, right? Yes, yes, yes. All right. Let's see. Sure. Excuse me. So that's part of the compare to. Again, equals. Again, I could set it equal to. You can do equals if ignores case, so that's another option. You can do that. So when you're comparing strings, then you don't have to worry about the case. You don't even have to do uppercase or lowercase to anything to make sure they're the same case. You can just say, you know what, I just want to check if the actual letter is the same. It doesn't matter, which is kind of cool. It's really kind of nice. Let's see here. So you never know when you might use some of these things. Again, these are just other things you can put in your toolbox. Empty strings. So a reference is a memory address with no characters. So when I created these programs here, I created fname and lname. Those were empty strings. So they actually use memory. They're in memory. They are created, but there's nothing in there, which is different from what they talk about here is called a null string. Null is nothing. So you've got empty strings, which it's a memory location which has no characters, where a null is. So a lot of times, programmers will create objects. They'll create strings, things like that, and they'll set them equal to null. Basically, it means it's equal to nothing, absolutely nothing. Okay, no memory address, no nothing. And you can use, there's an actual keyword called Java. Most languages have the keyword, null is keyword. SQL has it. They have one where you can check data in a database and say is null. So null is used everywhere. You don't want to use it as a variable. Strings are set to null by default. So if I did not assign, I can go back to this. If I did not assign, so let's do this. Let me do this. I'm going to take this line here and I'm going to copy it and I'm going to go right below here. I'm going to do a couple things. So we're going to do this, okay? And it'll print it out twice. So right now these are empty strings. So you should get a line that just has full name and nothing to display, right? Because these are just empty strings. They're not null strings, they're empty strings. And then I should get my full name printing out there, and then I should do the comparison there, which is fine. So let me build this. I just want to show you the difference between those. And then I run this. So there you go. So I get full name. I've got nothing that shows up. It's just empty. And then I get full name, and I get the actual name that we did, just like before, and then equal comparison. Now let's do one more thing. This time, instead of initializing these, I'm not going to do anything. I'm going to get rid of the initialization. I will put it back after this. I'm just going to do that. So I'm just going to do string fname, string. Let's see what it does. I can't even build it. What do you get? You get an error. It says variable fname might not have been initialized because I'm trying to use it. So I created a string. I did create this as a null value, but then I'm trying to use it, and then I'm getting an error. So if you ever get an error like that, where it says error might not be initialized, just smack yourself in the head, that kind of thing. You initialize. And again, that's why I always try to initialize stuff at the top, because that at least eliminates that error. So I eliminate the syntax error, programmatic error. So as soon as I put that back, I put the else back as equal to quote quote. I rebuild it, and we run it, and all is good in the world. Except we still have snow outside, so I can't fix that. All right, I'm gonna ask this. This is sidebar really quick. Record that. A couple of things I wanted to see. So we did the null. We've got that. Uppercase index. You can use something called. You can get the length. Length is great. The length of care. Think about this. When you enter, a lot of times when you're entering, you want to create a new password in a system. You create a new password. Typically, when you do a password, what do they almost always say? It says it must be between 8 and 10 characters, 6 and 12 characters, and you must have these characters. How do you think they're figuring it out? It's parsing that string that you're entering in. Very first thing it does is it probably just gets the length, uses a length method. I'm not saying it's doing it in Java, but every language has something like that. It's just kind of length. Hey, did you at least enter the right number of characters? Because if you haven't even done that, I'm not even looking at it. And it's like, oh, okay, you need at least 10 characters. You've entered 10 characters. Okay, now let's look at what you've entered. and then it goes from there. Then what you can also do is things like index of is kind of a cool thing. So if you're looking for certain characters within a string, you can search for that with index of, and it'll tell you where it is. So you might have a string. Let's say I'll go back to the code just for the heck of it. If I have a string, say like Bart, I have my string here, Bartfast. I could say, tell me where the first time you see A, and it would display that. It would say, oh, there it is. So 0, 1, it's at 1. And guess what? I have it also at this position. So it'd be what? 0, 1, 2, 3, 4, 5, and 6. It would be 0 based. So it would find the positions where you have that character if you're doing stuff. So for parsing, or maybe there's a space. A lot of times there's programs where you have to do parsing and break stuff up. A lot of times you look at data. Let me do this. I'm going to open up Notepad here. So you get a lot of systems and they'll have like John Smith, right? I'll make it bigger. That's really small. Make it much bigger. Now I'll make it even bigger. About 48. Okay. So you'll notice there's a space here, but some systems have it where it's just the name. But maybe you're parsing through a system, Mary space, I don't know, Jones, whatever, whatever. There's a bunch of names in this database, but I want to get the first name, I want to get the second name, because I want to put this in a database, right? And I don't want to put the full name in the database. Always want to break it down to its most basic data elements. In this case, the first John, John would be the first F name, right? So what you could do is you could do an index of on this string, and it will tell you that right here is where there's a space. And then you could break that apart, and you say, okay, so first name is John, then go to the next position, skip over this, go to the next one, and then count from there to the end, and now I've got my second grouping, and that's my last name. So you can parse. That's how you parse strings. You might have a whole bunch of stuff. Sometimes they'll have systems that have commas. I don't know if you've ever heard of that, comma delimited. That's very common with data. So you might have commas, and they might have an address, 123 Main Street, something like that, right? Comma. Now, the only thing we gotta watch out for is if there's a comma in there as part of the data, right? Then you have so commas sometimes aren't the best. Sometimes they're. More often than not, again, comma delimited, as you hear a lot of. Often that you'll also hear something called pipes. It's just above the enter key. It's a pipe. It's a vertical pipe, and that's a separator too. Those are very common separator. So you would do the same thing and have pipes. And the reason that a lot of programs will do that is because that's just not a very common character that's used. And normally commas again are used quite a bit. Could be John Smith Jr. or periods with a comma or something like that. And these are things, depending on what you're working on, you may run into. But that's how this index of works. It's kind of cool. So index of would go through, hit the pipe, boom, get that. So what you do is, again, like I said, index of, or I don't know if they give you an example there. But again, there's all kinds of examples. And we can display all this stuff. We can do length of strings. I mean, I'm not going to go through everything, but some of it's kind of useful. So I can say, let's do this. I'm gonna comment this out, // Okay, I have my test name. I'm gonna do this. I'm gonna say system.out.println, and just say length of Bartfast is equal to what? It's equal to test name.length. And I believe you have to have the extra parentheses on there. Let's see. It compiled, it ran. Now let's go. So then I've got, what does it spit out? So it spit out length of Bartfast is equal to 8 at the bottom there. There you go. So you just do the string name, dot, and then the method. In this case, it's length. So right away you've got that, and you can store that in an integer. You can do whatever you want. You have it later and say, hey, this is what they entered. It's kind of nice. Just spits that out. And that's a length. That's not the count. So again, how many characters? And you can always double check if you know 1, 2, 3, 4, 5, 6, 7, 8. Yep, that's right. 8 characters. So that's correct. If you have a space in there, what's going to happen? I'm going to put a space in there. I'll save it. So it was 8. I'm going to rebuild it. Rerun it. Guess what? Now it's 9. So you do spaces, anything else, it's going to take it's going to take up your space. That is also a common issue sometimes in programming when people are comparing strings and all that, and sometimes you just can't see it. You visually cannot see it. I had a student who had 2 periods in this one thing one time and drove me nuts. I couldn't figure out what was wrong. It looked perfect. The code looked great, but she was doing something calling a method, but she was doing with 2 periods. I just couldn't see it. So weird stuff like that. So sometimes you run into data where there might be an extra character or space or something like that. So length function will come in handy because then you can see it and you can say, oh, wait a minute, this isn't supposed to be, how is this 9 characters? This should be 8 characters. You know, I'm using my fingers and my toes. I'm counting, Bart. Right? So heck, get a little thing in and even put like a number there, right? I've done that before. I'm not too proud. I've done this. Do 1, 2, 3, 4. You can see it's going to get bigger. 5, 6, 7, 8, 9, and then obviously 10. So there you go. Then I know for sure. Oh, yeah, 8 characters. It should be fine. I printed code out, and I literally with a pencil gone through and traced stuff. So hey, it's 8 characters. So just again, I can leave that in there. I'll comment it out. So whatever you need to do to make it, again, simple. Break it, keep it simple. KISS, right? Break things down, make up smaller pieces of the puzzle, right? I don't know how many of you have done puzzles. I'm not a big puzzle person, but usually you don't do the whole thing at one time, right? You're always doing pieces. You're doing borders, and you're doing pieces around, and then you find similar patterns. You look at the picture. Hey, there's a boat. Let me find parts of the boat, or whatever it is, whatever you're doing. You break it down. You keep it simple. So let's. I've just got a couple minutes here. Let's do this. That'll be one of your Udoits because, like I promised, I want to help you get your Udoits done. Then you've got less to worry about. So I'm gonna do File, New, Java. I'm gonna grab my chair. Down to the 3rd floor. Okay. Okay. Make it bigger. So what do we do? So this is repairing. So we're gonna use what's called the swing library. Java X swing. So import Java X dot swing dot star. So the star asterisk, all that means is we want everything in that library. It's saying, give me everything in that library. Public class. And let's go repair name. Open curly, close curly. And then I'll just set up basics and then I'll save it. Public static void main string and then args again. Okay. And I'm going to save that as repair name. I'll overwrite mine like so. Okay. What they're going to do is we're going to create an application, ask for user for a name, and then fixes the name so that the first letter of each new word is uppercase. So it's like the proper casing. That's what's going to happen. So you can enter whatever name you want, John space Smith or whatever it is, Mary space Sue, Bob space Gonzalez, and it'll fix the name properly. Okay. So I'm going to come up. So in order to do that, I need to create some string variables, and I'm going to have a name. And they also, I'm going to do a comma, and they want to have one called save original name. Again, you can call them whatever you want, just as long as you understand what's happening with them. Okay. And they actually going to get the string length. We're going to use that. So string length. Oops. That's just an integer variable. Another int called I, a char called C. Okay, now they're going to use JOptionPane to show some of this stuff. So we'll see how this goes. So name is going to equal whatever value the user enters from the JOptionPane. So name is equal to JOptionPane dot show input dialog null, comma. I'm going to be rude. I'm not going to say please. I'm going to say enter. Enter your first and last name. Like so. Okay. So we're getting the user. It's going to display a graphic pop-up, and it's going to ask them to enter. Make sure you save. And again, if you want to build it each time. Make sure everything builds okay. You don't have any problems. It's fine. Whatever way you're getting into doing it is fine. Okay. So we're getting the name. The name came in from the user. So the first thing we want to do is we want to save it, right? So we're going to use that variable called save original name. I'm going to copy that and I'm going to paste it. And I'm going to say that is equal to whatever the user gave us. So I have a copy of it now inside in memory. Then I'm going to get the length. GTH. And that is going to be what? It's going to be name dot length, like we just did. So I'm going to get the length. And the reason I'm getting the length is because I'm going to set up a for loop and I'm going to parse through it character by character so I can see what's going on. And you can do that. Again, like I said, that's how they validate passwords and user IDs and all that kind of stuff. They go character by character. So we're going to do a for loop. For. Now I is already created as an integer, so all I have to do is say I is equal to 0. I'm going to initialize it to 0. Okay. I is less than string length, and then I plus plus. Open curly, close curly. So I've got my for loop set up. We're going to have quite a few things in here. Okay. So the first thing we're going to do is we're going to use this char C we created, char, however you want to say it. I say char all the time. That's just me. C is equal to name. So name is the string that we're still working with from the user. Dot, and we're going to use one of the methods, char at. So we're going to grab the character at location, in this case, location I, which is whatever is in the for loop. So it's going to start off at 0, right? And it's going to do each one all the way up until we're done with the string length. And again, you can print out at the top, you can do a system.out to say how long is the string I'm doing, so you know for sure that it's going through it correctly. Sometimes I do that if for some reason I get stuck in an infinite loop, if I do something silly or dumb. Okay, so I'm going to get that, and it's going to say if what I is equal to 0, what that's saying is if I is equal to 0, that is the first character, right? So we're going to open curly and close curly. So if I is equal to 0, it's the first one. So what are we going to do? What we're going to do is take the character. We're going to assign it what? We're going to assign it. We're going to call character dot to uppercase, and we're going to pass it C. So it'll take what we send it, it'll uppercase it, and then it'll return it, and C will now have that new value. Just by doing that. Then we'll go back to the original string and say name is equal to, stay with me on this one, C, which is the character, which we just created, that's capitalized, plus, this is the fun one. You're going to take name, again, where we are, dot substring. We're going to take a substring. We're going to take a part of it. Because we're creating this, I don't want the whole thing, right? So here's an example really quick. I'll show you. Let me get rid of some of this. So if I enter, say, John space Smith, right? Okay. It's going to grab the first character. and it's going to make it uppercase. So I'm going to come down here and it's to say, okay, now I'm going to say the first character is now J, capital J, right? But I want the rest of the string to go with me. So what's going to do is take a substring of that. It's going back to the original string, and it's take a part of it, starting at the next position. I don't want to go position 0. I want to go to the next position. So it's going to go substring. In this case, starts at where? 1, because it's going after the first letter, comma, and then just the rest of the string. In this case, it's just string length. So what it does is it creates this new string, and literally, and then you just take this, and then I'm going to copy this, and then it puts it like that. It puts that all back like that. So now the second line after this, if I was to print this whole thing out again, it should look like this. Okay. And if you want to, you can do that. We can do that. So I'll tell you what, we can do some of this. Let's do this here. Let's just do. And I always think it's handy. I'm not going to do everything at the moment, but let's do this. So at least we get the first part of it. I'd rather do that than do it. So let's do this. So first of all, what I'm going to do is say system.out, and we may have to take a break in a couple of minutes. We'll do this first part, and then we'll take a break. And I'm just going to say string length. What's a string length? Just so I know. I'll do quote string length is equal to quote plus length. Again, I'll do that for my own. And then I'm going to come here, and I'm going to say if I is equal to 0, I'm going to just, it's going to print it out one time. I just want to see what it looks like. I'm going to see if I'm right. And I'm going to say name is equal to, and then do quote plus and say name. And then you can say I'm inside if whatever, if you want to, you can say that. Or you can put name, say name 1 or name 0 if you want, because you know that's where you are, name 0. Because it should only do this once, right? Because I should only be equal to 0 one time in the for loop, right? It comes in the for loop, it does its thing, and it should do it. So let's see what happens here. Let's just build this. Again, it's going to look kind of, oh, I missed something. Oh, right, string length. Okay, missed that. Build it again. And sometimes it doesn't always look all that great because you're in pieces, but you're getting parts of it the way you want it to work. So we got that. Let's run this. So I'll enter my first and last name. So I'm going to stick with what we did. I'm going to say all lowercase John space Smith. Okay. And I'm going to hit OK. Okay, so there we go. String length is 10. So the question is that correct? So I can do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it includes spaces. And guess what? It did exactly what I said it was going to do. It took the first character, capitalized it, and then just put the rest of the string on there like that. So Smith didn't capitalize yet. That's it. And that's all that happened in this program. It just stopped there. It stopped because that's all we had. Because all we do is check for 1. So it's the for loop is still going. It still goes through that whole string, but because we don't really have any other checks, we don't do anything else, and we don't see anything else, right? So why don't we take a break? I'm going to pause this. So we got the first part of it set up. Here's our for loop here, right there. So again, sometimes what I like to do, and I think I showed you this, I'll do this too, because we're going to get far. So I'm going to do // I'm going to say end for loop. It's up to you, but we're going to push stuff back a little bit. So end main. I mean, you could do even down here. You could say this is my main, because this is. I mean, you can see this is getting kind of. Unless I start making my code really small, it'd be hard for you to see. If I do main, I might do this and just say and main method. Just something that I've kind of gotten used to doing. Because now what will happen is we're going to put an else in this if statement. So we're going to have the if statement here, right? And we're going to do an else. Say else. And then inside the else, we're going to do another. We're going to say if. It's going to check now. We got to get the other characters. If, it's going to look for the space. So if name dot char char at, let's say char at I, and it's to say is it equal, and then use a single tick mark, space, single tick mark, like that. And it's going to check for that space in that, again, in the name. So here's our space. It's looking for this right now, looking for that space. So if it finds it, what is it going to do? Open curly, close curly. Now you can see why I did some of this stuff, because now stuff is getting pushed back further, further in there. So, and then actually this else, that part of that if, we got this in there, okay. So I'm going to do this. All right. So now if it is, we're going to do what? We're going to increment. We're going to increment I. How many times it did that? So it finds a space. C is going to equal what? C is equal to the name dot char at I. So I'm in the loop. I is 0. I is the counting. This is kind of the weird thing about it. The for loop controls I. That's the controller, right? I is the variable that's being controlled by it. I goes 0, 1, 2, 3, all the way up through there. You'll notice that I++ is over here. It's there. The for loop is controlling that. But then I'm doing that here. I'm doing that here because I want to get past the space. So I can do it. So I want to go to the next one. And I'm going to go to the first character past the space. I grab it, and I'm going to say C, do the same thing I did before. C equals character dot to uppercase C. So now I make it uppercase like so. Okay. And then finally what I do is I say name is equal to what? Is equal to name dot substring. There's that substring again, right? So name is going to take whatever I put in it. So name dot substring. So here we go. So 0, comma 1, or comma I, I'm sorry. So substring, it's going to start with that. So it's going to grab the first part of it, what we've got there. And you're concatenating C on there. And you're concatenating name that, yeah, and this is crazy, it is. And until you kind of get used to some of this, it's just kind of, yeah. And then you go I plus 1, and then it's going to pick up the rest. So that'll get us the rest of then the last name. String LENGTH, like that. So name.substring is going to get the first from 0 to I. We'll get that. And C, we'll get the character there, and then name. Because we already have capital. What this is doing right here, this whole section is doing, it's grabbing, and I'll make this up here, so it's grabbing this whole piece right here, right? Then C is now the uppercase C, and it's doing the same thing we did up above there. It's taking C, which is now, this becomes a capital S, and then it's going to do the rest of this, and it's going to put the rest of that on there, and it gets the rest of that. So I plus 1, so I is S, plus 1 is the, I plus 1 is that, because I is the space, I plus 1 is that, and this. So yeah, it's crazy, and you really sometimes have to go, it's not difficult, but you really have to kind of take it piece by piece and get that. But once you have this little algorithm set up, because that's what you're doing, you're developing an algorithm, and you got it, and you've tweaked it, that's it. You don't have to do anymore. And then the string length just gets the rest of the string there, like so. Okay. So I think we got all that, and we're good. And then make sure we close that for loop, which I did. I put that in there. That's why I put that comma in there, end for loop, end main method, just so I don't miss it. I'm going to compile this to make sure I didn't blow something up here. All right, so it built. All right. So then it's going to, what it's, in this case, in this case, so it's going to go through every character, right? It's going to check everything and make sure I've got it. It's going to everything. And the biggest thing all we want to do is we're checking for the first character, Then we're checking for the blank. And then once we have the blank, we know that the very next one. Now, here's the presupposition or assumption, which, again, you don't want to assume, right? That's the worst thing you can do. You're assuming that a user is always going to get rid of this. You're assuming a user is always going to enter the data like this. And for our purposes, that's okay. In the real world, it's not okay, right? You can't assume people are going to do this because they're going to do a whole bunch of crap that you don't know what they're going to do. But for this purpose, it's okay. And there are other ways that you can check around this. As you get more proficient and more experienced in some of this, you can do that. But right now, we're assuming we're going to have first name. There he is. First name, space, and then last name, like so. Okay. So it's kind of crazy. All right. So right now, what we'll do is they're just going to spit. Then what they'll do is they'll just spit out the result. I've got all this in there. I'm good. Once it's done, everything's hunky dory. So once I'm done with the for loop, I've gone through everything. This is exactly why I put this end for loop here, right? Make my life easier. Outside the for loop, I've already gone through everything. I'm just going to print out. I'm going to display it. I'm going to say J option main dot show message dialog null, comma, and then they've got this whole thing. I'm going to say, I don't know, I'll say original. I'm just going to say original. I'm not going to go into all this. Original. And I'll say quote, I'll say plus. And so the original name was what? It was that string. If you don't remember what it is, just go back and find it and copy it and paste it. Save original name. So that was the original name. Okay. Plus, then what they want you to do is make it look a little nicer. And in the quotes, you do a /n, so carriage return, so it looks a little bit nicer. And say, they say repaired name, that's fine. Repaired name. I'm going to say repaired name just like that. Quote plus, and now it's just name. Like that. I'll make it a little bit smaller so you can see it more on the screen together. Like those. I'm not going to get rid of it. I'm just going to build it, make sure I didn't miss something. Okay, so everything compiled. Make sure it builds okay. You didn't miss a semicolon or anything. Again, the reason I did the end for loop in those comments there, it made my life easier because I was missing curly braces. I was figuring it out. We were just talking at break about that. It's so easy to do. All right, let's run this and see what happens. It's kind of nice here. So again, I'll just do what we've been doing. So John space Smith should give us a capital J and a capital S, right? I know, very exciting. And there you go. Original name and repaired name. There you go. All that for that, right? You're like, geez, I could have solved the world's problems by now. And then okay. Now it only runs one time. So again, you have other things where you could do is you keep running it, but that's okay. So again, the basics code is you've got a loop. The for loop wants to go through every character. So we know that at the outset. It wants to go through every single character. Then once you get inside that, it's easy because what your goal is, capitalize the first letter of the first name and capitalize the first letter of the last name. That's all you're doing. And the way they're doing that is the first one's super easy, right? It's just position 0. If it's position 0, hey, capitalize it. We're done. And then just put the rest of the string on there. We got that. And then otherwise, if it's not the first position, then it's going to say, well, hey, is there a space there? If there's a space there, then we know we're close to the last name. And then you do the same type of thing. It gets a little bit more complicated because you're adding, the first name, blah, and make it look the same. So sometimes you got to tweak it and play with it, but that's the gist of it. I hope this makes sense. I think just kind of going through with some of this. Down below. Yeah, sure. So now we'll do number input. Again, save your code, play with your code. I mean, it's good to build off of because you could use this for any kind of thing. And like I said, for the final project, if you want to do with the J option pane, that kind of thing, that's fine. I have no problem with that. I want you to have fun with it and do stuff. Have fun with Java, huh? Is that kind of an anomaly? All right. So we're going to do a class. We're going to do import first. Again, we're going to import the JavaX swing because we're going to use J option pane again. JavaX.swing .star. And this class is called number input. Public class number input. Oh, I don't know why I've been doing lowercase on that. So number input, I do capital and capital I, just like that. Open curly, close curly, and then we're going to do public static void main. String args. All right. Okay, so we have our structure that we're so used to doing. So the idea with this one is we have prompt the user for a number, read it from the keyboard, store the characters in a string to do for math, to do calculations, because obviously you can't do calculations on a string. So we're going to save this as number input. I already have it. I'm just going to overwrite mine. I'll do it again. Do this. Okay. All right. So what we're going to do is we're just going to declare some variables to do this. So we're going to say string is input string. That's what we're getting from the user. And then int is going to be the input number. So we're going to convert the string to a number. And then finally the result. We're going to spit out the result. We are going to create a constant, final, for factoring. Final int, it's an int, and factor is equal to 10. Okay. So we've got an input string, which is a string, and then we have two integers, input number and result. Okay. So again, we're using J option pane to get the values from the user. Otherwise, we could use scanner, either one, but in this case, we're doing J option pane to do it. So input string is the string that we created. Getting the value from the user from that is equal to J option pane dot show dialog. Show input. Sorry, show input. We gotta get input. So input dialog null, comma, enter a number. So you're asking the user to enter a number. Make it a little bit smaller so you can see it better. Like that. Please enter a number. Okay. I'm gonna save this again, and I'm gonna build it just to make sure I didn't make a boo-boo. And it's building. It built okay. So again, just an idea if you want to. You don't have much code, but it's just nice to have it. Okay. Now what we're going to do is we're going to parse we're going to parse this. So I have a string, and we're going to parse this value. And what it says is you can use the parse int to convert the input string to an integer. So that's how you do it. So some languages call casting, where you cast something from like a number to a string or from a string to a number. You can do that. A lot of times when you get input from a user, it comes in as a string. Sometimes when you read information from a database, it comes in as a string. So then you got to convert stuff, which normally would be like, say, a 5. Like, well, that's a number. Well, it came in as a string, and so it doesn't know. It's kind of weird, but it is. So I can make that a string or a character. But you got to understand. So you got to understand. So that's why they're showing you how to do this, or one of the reasons at least. So input number, which is the variable we created, is equal to integer, because I want to create this, because I want to be able to manipulate it. It's parse int, and then the value is input string. So it's going to take whatever the user types in, passes that parameter, and it's going to make it into an integer. It just converts it. And we're going to play with a couple of things here so you see what happens. So if I enter a letter A, which is not even though it's a string, it's not an integer. When it tries to convert it, what's going to happen? And we'll play with some of that, and you'll see. So then the result they just want to input number. They want to multiply it by a factor by your constant there, just to do some calculation. And then finally, they just want to spit it out. J option main dot show message dialog, again null, and all we're doing is we're just showing the actual values. You're going to say input number, and they want to say equal a plus quote star, so you can see that star plus factor plus quote. I hate doing all this concatenation. It drives me crazy. I don't like to do it this way, but I'm doing it because that's just how they have it in the book as a result. So the basic thing is you're just showing the input number, character times factor, and then what the result is equaled. We already have all that information, but we're doing it so it looks nice and pretty. I like it pretty for the user. All right. I'm going to build this thing. And let's run it. Let's see what happens here. So enter a number, and I'll enter a number, I'll say 5. So 5 times 10 is 50. So it did it. Okay. And from this perspective, you're like, oh, that doesn't make sense. Well, because it comes in as a string. It's taking it as a string here, and then it's doing the conversion. What happens if I run this and I put in a letter A in? What's going to happen? It blows up, which is not good. And the exception I get is what? Input string A, format number, integer %. They can't parse it. Number format exception. Okay. So it can't format the letter A. It doesn't know what to do with that. Right. So it's actually looking for a number. So obviously, if you were going to use this code in production, you would want to catch that and say, you cannot enter an A. No A's, no B's, no letters. You got to enter something between whatever, 0 and 9 or whatever. So I'll rerun it. And how about if I enter 999? How did that do? 99, there you go. So, again, it's a primitive example, but again, the idea is, and you can go both ways. I can take an integer, again, and go the other way. But that's the most common thing to do. Some languages, again, call casting, where you're casting from one data type to another, because you're going from a string data type to an integer data type. That's it. So let's see, index, we talked about a lot of that. Concatenation, we've been doing that. Strings, substrings, we did substring that we've done a lot of. It's just something, I gotta stand up. I've been sitting too long. Substring is something it's a great method. It's a great tool. I use it a lot, depending on what you're doing. But like I said, when we did the repair name with the substring, I mean, you can see we use it several times. And again, it just takes a chunk of the string out. You can take the string out and make it so it doesn't affect the string. You can make new strings out of that. That's all it's doing. So it's really kind of nice. Extract just parts of a string. Again, first position, wherever you are, and then get the rest of it. If you don't put nothing in there for the end position or whatever, it'll just take the whole length of it, the rest of that string for you there. That's it. Really kind of nice. Let's see here. A couple other things. Again, I promised you I wouldn't bore you with it. Again, integer class, %. This is what we're just doing. Java language, indexes. I'm not going to go through all that. Okay. String is fixed. String builder. So then it gets into what they call these string builder classes in the book. So there's a string builder and string builder classes. This is in Java, the value of the string is created. Strings are what are called immutable or unchangeable. Immutable. When you write, if I write something like this, is what they're saying. If I write like that, it doesn't nothing. That's it. Some string. That's just all it's going to be. So if you follow it, or if I do this, if you do it again, what they're saying is if you write something like that and then follow the same thing, I have another piece of content of the address represented. All I've done is character representation. So the memory address is still the same. Once you have the sum string there, this is what we were talking about before with memory addresses. Again, strings are kind of weird that way, but just it's just the memory. That's so what happens is the idea behind string builder and string class supposedly makes things more efficient. It's an alternative to the string class, and you use it when you want to modify things, and you can use anywhere you use string. It's part of the package, and it's automatically in the language there. So it's all part of it. And supposedly string builder is more efficient. Oh yeah, that's what I said. String builder is more efficient. String buffer, on the other hand, is what they call thread safe. Threads are memory that go off, and applications run, they run on threads, is what they call them. And you can kill different threads if you want. So in order to do that, in order to create string builder, you actually use the term string builder to create something with it. Again, it's an alternative. It's used when a string will be modified, and you can use anywhere you use string. I don't use string builder a lot. I use string typically, but this is how you would do it. Again, this is another tool in your toolbox. How do I do it? Instead of calling string, you call string builder. That's it. String builder, what your string is, equals new string builder, and there you go. You have to use the keyword new. So in this case, you can't do kind of the thing that we did before, where we just did string and then blah, and then variable and that, how we've done it here. You can't just be as simple as this, string space name, like that. You have to use this full syntax of it, the full constructor name. And that initializes that string builder object for you. Okay. So you get a buffer which may or may not contain a string, and the string may or may not occupy the entire buffer. Again, the idea is it's more flexible than a string. So the string might not occupy the whole thing. The length of a string can be different from the length of the buffer, which makes sense, right? So you can have a buffer. So again, if I have a string like this, say this is the whole thing, it's hello, but the buffer itself could actually be like a lot bigger. It could actually look like this, and I'm just using this for representation purposes. Doesn't mean this is what it is. It could be like this. I could have much more space there. It could be like 30 characters, 40 characters. The idea is variable length. It's not locked in. That's the whole. That's all they're saying there. So it might not be, and the reason is potentially it's more, like I said, more efficient. You're saving space, that kind of thing. So that's why they suggest you can set the length. You can change the length of the string in string builder object. You can get the length, and you can find the capacity of that object. So you can set the length like a regular string if you want to. Again, it's just another tool for more flexibility. And then examples, I don't know if they show here, same thing, different examples of using string builder. So you create a string builder called name string. It goes new with, and they load it up with the string value of Barbara. It checks the capacity, what the capacity is, and puts an address in there. So you can use it if you want to. There's nothing wrong with that. The book has, and then there's different methods also. You can append to it, insert at certain places in the string itself, and the characters. So you have methods with this also. So I can just append, add on to the end of the string if I want to. I told you it's exciting stuff. So let's do this. Let me go back to this. Let's do the string builder. This is the last one. Let's do that one. And then we can talk about some more stuff we want to here. All right. So let's do the string builder class. You can play with that. At least you have a taste of it then. File new, Java. Okay. I'm going to clear that, and I'm going to close that up like that. All right. So it's built in, so you don't have to worry about it. So you can just do public class. We can create a class, and they're calling this one string builder methods. Very original, very exciting. Open curly and close curly. So we're going to create that, and we are going to do a main method. Public static void main string args. Again, open curly, close curly, like so. Okay. The excitement builds. All right. Oh, yeah, so I got to save it. Save it as string builder methods. I'll save it. Yeah, I'm overwriting everything. The world. Okay. So, remember, you got to use the actual terminology. String builder space, whatever they want to call it. And luckily, we're going to use something nice and short called str equals new space string. Does this remind you of something else? Remember we were doing classes? Create a class equals new class, instance of that class, scanner, those types of things. So it's the same kind of syntax that you're doing. So we're going to do a couple. This is kind of a goofy one, but we'll do it. Singing. You're putting together a song. So we're going to have a singing, and then we're going to say system.out.print ln str. And then you're going to print out what you just did. Now we can build this. Make sure that builds. I can run it, and I should get one line. I get singing. Yay! There you go. That's it. Oh. There's more, because we'll use a couple of the other methods. So now I'm going to go in. I'm going to use like the append method. I can take str.append. So I'm going to append something to the end of that. I'm going to do quote space. I'm going to have a quote. So it's going to be singing space in the dead of. What is it going to be? All right. Guess what? We're going to print it out again. And I am going to be lazy, and I'm just going to literally just copy this line above and paste it. And again, you want to check it? We can check it. We got 2 lines now. And how did it work? There you go. So I went from singing to singing in the dead of. So those 2 came up. Singing and then singing in the dead of. Cool. So that's using the append. Just adding in. Now, because I made a boo-boo, which I really didn't, but they want me to make a boo-boo, is I'm going to do an insert. And with the insert, you have to tell it where you're going to insert something into. And you got to, so this is a value. In this case, it's 0. I'm going to insert this at the beginning. Comma, and then what's my string? I'll say black. Quote. Okay. Guess what? We're printing out that line. So I'm just keeping that in memory. You want to? You can build it and you can run it. Does this get tedious? Yes, it does. But at least you can see what's going on. Singing. Singing in the dead of. Black. Singing in the dead of. So it's kind of hodgepodge right now, right? We're getting there, but you can see what's going on, okay? Not rocket science. You can see how stuff is getting built. So now they're going to do another insert, str.insert. Where are they going to insert this one? This one is also going to be not at 0, but they want to insert at position 5. So they want it at the end of the word black, right? So that's 5 characters, so 5. So go to 5. You're going to insert, because I want to have bird in there. Gotta have bird. Not big bird, bird. Just plain old bird. Like that. Larry Bird. Okay. Guess what? We print it out again. Let's run it again. Do a couple inserts, hit append, run that. There you go. Blackbird singing in the dead of. So blackbird singing is all together, is smushed. So that doesn't look too good, right? So actually, I must have missed a space. So I'll do a space after bird. I think they have a space. I'm putting a space after bird here. I missed it. And then finally, so blackbird singing the dead of. We have one more line, and that's probably what? An append. It's at the end. I'm going to append night, right? Blackbird singing the dead of. You guys know that song? It's an old song. And guess what? And we're going to append that again. And we're going to build it. And we're going to run it. And you can see every iteration. Singing in the dead of night. So hopefully it looks something like that at the bottom. Blackbird singing in the dead of night. Now obviously you can get rid of all the other stuff and just print that last line, but they want to show you how it looks along the whole way. So you build a string builder set up, and then I can use an append, I can use an insert. Is one way better than the other way? I mean, because you can use concatenations, you can do all kinds of stuff, you can do the substring. Again, supposedly it's more efficient. It just depends on what you're doing, and it depends on the code base you're working with. If you're working with a system that it wants you to do one thing or versus another, then you need to do it that way. Just another tool in your toolbox of what you can do. Hopefully that makes sense. Then for the homework assignment is validate password. So let me go here really quick. So it's number 4, I believe, right? US7, exercise number 4, validate password. So there you go. So write an application that prompts the user for a password that contains at least 2 uppercase and 3 lowercase characters and 1 digit. So it's like a password, right? What is a password? Continuously reprompt the user until a valid password is entered. So you got a for loop, right? Or something like that, or a while loop or something. Something that says, hey, keep telling me until I have a valid password. Displaying a message indicating whether the password is valid. If not, display the reason the password is not valid. So the idea is with some of that is if they enter something, and I'll just do this, I'll make it a little bit shorter over there. I'll go like this. I'll put it up here. So if they enter something, what do they want? So they want a password contains 2 uppercase, right? So I don't know, say TT, and at least 2 lowercase, at least 2 uppercase, 3 lowercase, AAA, and 1 digit, like that. So you'd have to do, again check, and it doesn't matter the order either, right? Doesn't matter the sequence, so they could go TA 5A like that, right? So you're going to have to then count. And how many do they want in there at least? They want, so 1, 2, 3, 4, 5, 6, right? So at the very least you're going to do is just check for 6, at least they have at least 6, the length is 6. Then you're going to say, you're going to check each character. Do I have an uppercase? 1 uppercase? Oh yeah, I got uppercase, whatever it is. I have another uppercase. Doesn't, now again, that doesn't have to be an A, that could be whatever, that could be a U, right? And this could be A, and this could be a B, and this could be a C. So they could be all different, right? Everything can be different. And just go through and go each character, just like how we just did it. Check each character, What is it? Is it uppercase? And then have a counter saying, I have a counter. Every time I encounter an uppercase letter, boom, I've got one. I got a lowercase letter, oh, I've got one. I've got another uppercase, okay, now I've got 2. Now I've got another lowercase, now I've got 3. 2 lowercase, 2 so uppercase is done, lowercase I got that, 5. So if they don't fulfill it, you can say, hey, you need at least 1 more uppercase or 1 more lowercase. Does that make sense? So you're going to want to keep a count of uppers, lowers, and then a digit. They may enter everything and don't have a digit, things like that. So that's the idea behind it. Keep it simple. What I would do is just try to kind of start off basic and just kind of go from there. But a lot of what we've already done in class with some of this, especially not the number input, the repair name. This is great. I mean, because you can kind of go through that. They enter something and you can just check what it is. And you've got the things like, remember, you've got the is digit. So is digit, you can check. There's your digit right away. So you could go through the thing right away and say, is there a digit? If there's at least a digit, boom, that's satisfied, right? And then you have to look through for characters. So however you want to do it, there's a whole bunch of different ways you can do it. This might be a good way to start an example, kind of going through something like this to do that. But that is the assignment. But that's it, just number 4. So, and obviously making it user friendly with messages saying, hey, this doesn't make sense or whatever, that kind of stuff helps too.